So here are some of the features that we're shipping for Unreal Engine 4.23. I won't go through them, it's all in the blog. But as you can see, a lot of stuff that is relevant for virtual production and filmmaking. And to demonstrate how all this stuff comes together in a combined filmmaking workspace, check out this video that we put together from our test stage here in LA with a whole bunch of friendly companies that we've been hanging out with that shows the potential of when you bring it all together. OK, roll the video.
Great, let's cut and reset.
No matter what the project is, the creatives always want to see the closest representation to the final product as early on in the creative process.
When I first walked onto set and the wall was up and we started to look through the camera, it really started to feel like I was just filming in this actual location.
We can track a camera's position in space in real time and render its perspective so that we can compellingly convince a camera that something else is happening in front of it that really isn't there.
The thing to keep in mind is that the 3D world that you see on the wall is also a 3D scene that you can manipulate in Unreal Engine. So this gives the filmmakers full flexibility to make any change they want to the scene live.
So it's really exciting to see that we can, use the real-time lighting to not only change the environments virtually, but also have it affect the on-set lighting as well. This opens up kind of like a virtual playground to shoot in.
With a VR Scout, you have your department heads collaboratively going into the world together. They're able to make decisions that inform the creative process down the road. It gets them more grounded into the scene that they're shooting, into the story they're trying to tell.
Because you can interactively change the world, it brings all of those departments together because each one of them has a role in how this world is portrayed at some point along in the production.
The director and the DP, they're back, and they're now able to work directly with the teams in real time. It's a really exciting creative process to be part of.
Cool. So this is just the beginning of an emerging field, and we're super interested to hear your vision of how you would like to use Unreal Engine to create and tell new stories. So for our next speaker, I'd like to introduce...
Wow, thank you. I am from Walt Disney Imagineering. My name is Bei Yang. For those of you guys that don't know, Imagineering is the creative center of the Walt Disney Company. And we're really responsible for creating theme parks, resorts, but really it's about the guest experience. And more recently, we've just opened up Star Wars Galaxy's Edge in Disneyland Resort. In fact, so you can go to this right now. Now, what's amazing about Star Wars Galaxy's Edge is it immerses our guests in the universe of Star Wars. And it's really about wish fulfillment. And what's the best wish, at least for me, is to be able to pilot the Millennium Falcon. And this is, a dream I've had since a little kid, watching Star Wars for the first time. Now, if you take a look at this, right, we actually allow you and 5 other friends to go and be pilots on this magnificent ship. And I can tell you that from firsthand experience, that when I put my hands on that lever and I pull it and I get to go into hyperspace, that is wish fulfilled. Now, this is something that we've been working on for a while, right? And we've been trying to develop technology to be able to do this for quite a while. And these are some of the problems we have to solve, right? We want to be able to immerse you in the ship, and we want to be able to render everything in real time because we want you to be able to pilot the actual ship. So all of these things we had to solve: field of view, resolution, rendering fidelity. Now, field of view, right, what do I mean? When you have a 3D game engine running a game on your living room television, it's really just a rectangular screen. How do you blow that out to an overall cockpit? And then through all of that, we want it to be perfectly eye-limiting resolution, so that means about 5,400 pixels horizontally. Now, when I talk about resolution with field of view, I really talk about this problem, right? For anybody that's a rendering engineer in here, you can't really just push the view frustum and make it wider. You get into this resolution problem. So in the world of VR, traditionally you render out a cube map and then you reproject that cube map back onto a dome. And that's precisely what we've done with 5 projectors, and we actually put the cockpit inside a dome with 5 projectors. So this means that we don't have to render the back. That means we have to render about 3K per cube, 5 cubes. So that's the target for anybody that's interested in rendering in here. And of course, not only that, we also have to have rendering fidelity. So this is getting all of the full screen effects to actually work in a cube map, which, by the way, none of those algorithms that are actually developed for rendering those things are made for a cube map. So working with NVIDIA and working with Epic Games, we really had to do this such that we can have 3K per cube, 4 cube faces at 50 hertz, and still have all of the rendering fidelity. Now, if you take a look at traditional gaming hardware and what's there, right now, this is not possible with this type of resolution and this type of fidelity on the rendering hardware that we have available today. So we turned to multiple GPUs. Now, some of you guys are, of course, gamers, and you guys have built gaming rigs. Multiple GPUs usually means about 2, 3 GPUs kind of SLI'd together. Well, we have this thing in which we have kind of essentially 4 views that we have to render out, right? Front, left, right, top. But what we really want to do is parallelize them. So, you can do this on 4 GPUs, but we didn't stop there. We went with 8 GPUs. So this is actually the highest amount of GPUs you can currently shove into a machine. And it's very loud when you recool this thing, but I can tell you it's kind of a beast. So this combined with alternate frame rendering, we were able to produce the visual fidelity and the frame rate that we wanted. And of course, working with NVIDIA and some of their very Quadro-specific features, such as SLI mosaic mode, we were able to bring that to the 5 projectors that's needed to create the experience Smugglers Run. So for those of you guys that are very technically minded in here, here is the actual benchmarking chart from Smugglers Run, and we can actually see the zoomed-in picture, right? Every single one of these frames rendering at 30 hertz and then presenting at around 50 hertz. So just in review, right? This is 3K by 3K 4x, so this is about 38 million pixels, pushing 60 million vertices per frame at 50 hertz, with 15,000 static lights, 200 dynamic objects, and about 20 cast shadows. Now, what's really interesting about this is, we worked with Epic, we worked in NVIDIA, and we really had to invent a lot of these things. But why keep it for ourselves? We've actually been working with Epic Games to push this into the main branch of the engine. And in fact, some of that tech has already been used. In fact, in the Reflections demo that some of you guys may have seen, some of that code was already being used. And in fact, in 420 right now, some of the RHI in DX12 is already in there. You just have to look for it, and there's a compile flag to enable it. But that only supports basic rendering. We're continuing to work with Epic Games to put more generic features in there for 424 and beyond. So with NVIDIA collaboration, we're also putting in their NVLink, which is a much faster bus than PCI Express. And this continued development really is what's going to allow us to push the industry forward and therefore allow everybody to create amazing experiences. So many of you guys have been sitting in here and probably have been hearing a little bit of a whirl. You can hear it right now. That's actually the 8 GPU machine back there. It's running. And we're actually going to show you a real-time demo of this. So what we're seeing now is the actual ride footage being rendered out backstage on an 8 GPU machine. And in fact, you can actually see some of our rendering stats up here. So I want to say that this is usually projected out in a dome. So normally what you would see coming out directly out of those outputs is this. This is actually what goes into the projectors, and they get warped into one logical image. So what we're seeing here is actually a visualization of what the dome looks like. In fact, I can zoom out. That's the complete dome that the cockpit sits in. So going through this, we can actually see this is being rendered fully in real time. Now, I'm not going to show the full thing because I want you guys to go in the park and see this. But I want to show you this, which is my favorite part, which is putting my hand on that lever, pulling it, and going into hyperspace. So with that, thank you very much, everybody, and thank you for coming.
Thank you, Bay.
All right, going into hyperspace. That was beautiful. Can't wait to experience this with my kids.